You know, we're surrounded by this thing. We're connected to it 24/7, but have you ever stopped to think how it actually works? I don't mean the websites or the apps, but the physical stuff, the actual pulse in the wire. Well, today, that's exactly what we're going to dig into.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
Okay, so let's kick things off with what I like to call the internet's grand illusion. It's this magic trick that's so good, so seamless, we don't even know we're the audience. See, on one hand, you think you're sending something, meaningful. A song to a friend, an important email to your boss, maybe even moving money around. But the truth? The physical network has absolutely no clue what any of that stuff is. To the actual wire, it's all just a jumble of ones and zeros. That's it. So to really get how this is possible, we've got to zoom in. Way in. We need to find the smallest, most fundamental piece of the puzzle, the single atom of all digital information. And there it is, the bit. It's the smallest possible unit of data you can have. It's just a simple binary choice, right? A 1 or a 0, on or off, yes or no. And from that one tiny, simple building block, everything else is made. Every photo you've ever taken, every movie you've streamed, even the words you're hearing from me right now. It's all just a ridiculously long but unique combination of these bits. I love this quote because it just nails it, right? The network doesn't care if it's Beyoncé or a spreadsheet. To the wire, it is all just bits. The actual hardware, the copper, the fiber optic cables, it's completely blind to what the data means. A multi-million-dollar bank transfer looks exactly the same as the latest pop song. It's all just a stream of bits. Okay, so this brings us to the big question, the huge puzzle that the pioneers of the internet had to crack. How do you possibly bridge the gap between this abstract world of information and the very real physical world of wires and electricity?
I mean, really think about it for a second. The number one is just a concept, an idea. A copper wire is a chunk of metal. You can't just, shout 1 into the cable and hope for the best, right? So how on earth do you translate that idea into a physical signal that can actually travel somewhere?
Well, the solution they came up with is frankly brilliant. It's both super clever and incredibly simple. It's a technique called modulation. And the best way to wrap your head around it is to think about something you use every single day, a simple light switch.
So, picture this. A standard network cable, like an Ethernet cable, always has a little bit of electricity flowing through it, a constant low-level charge. Now to send data, all we do is, we modulate that charge. We just change it up a bit. To send a 1, we give it a quick jolt. We increase the voltage for just a split second. That's like flicking the switch on. And to send a 0, we just let the voltage drop back down to its normal low state. That's like flicking the switch off, on, off, 1, 0, 1, 0. By doing this in a super precise pattern, we can send any combination of bits we can dream.
Now, this whole language of voltage changes has an official name, of course. It's called line coding, and it's a bit more than just flicking a switch randomly. There are really precise rules and timing involved. And that timing is absolutely crucial, because it's what makes sure the computer on the other end knows exactly when one pulse ends and the next one begins. Without it, your 1s and 0s would just turn into a messy, useless jumble.
All right, so we've got our analogy, an electrical light switch, flicking on and off to send 1s and 0s. Simple enough, right? Well, now we're going to take that simple idea and scale it up to the absolutely mind-bending reality of modern tech. Let's talk about speed. Yeah, we are not talking about flicking this switch at a human pace. The speed at which this happens is, it's almost impossible to really wrap your head around.
In a standard modern network cable, like the one maybe plugged into your computer right now, that flick of the switch, it's happening 10 billion times every single second. 10 billion bits of information are racing down that copper wire in the time it just took you to blink. It's insane. So let's just pause for a second and let that sink in. 10 billion. This isn't just some number on a spec sheet. It's a quiet, invisible miracle of engineering that's happening all around us all the time.
I mean, the sheer precision of it all is just staggering. The ability to control electricity so perfectly that you can create 10 billion distinct, separate pulses every second and have a device on the other side read every single one of them without a single mistake, that is a hidden marvel that powers our entire modern world.
So, what does this all mean? It means that when you peel back all the layers of our digital lives, the apps, the websites, the cloud, all of it, what you find at the very, very bottom is something astonishingly simple. It's just a tiny pulse of electricity, flicking on and off, billions and billions of times a second. It really makes you wonder, doesn't it? What other huge, complex things in our lives are built on a foundation that's just as simple and just as profound? Thanks for digging into this with me today.